Okay. The unit number 2 basically consists of two sections. First is nothing but major electrical equipments, and second is nothing but inductance. So in this second part, we have to calculate inductance of different transmission lines. Okay. Now single transmission line is there. We have to calculate inductance. After that, we have to calculate inductance of three-phase line. After that, we have to calculate inductance of double circuit, double three-phase lines. Okay. After that, we have to calculate inductance of if the transmission line are unsymmetrical in nature. We have to calculate inductance of line when the transmission line are in symmetrical in nature. Okay, that means inductance of transmission lines we have to calculate in the unit number 2, and that's section number 2. Okay, and the unit number 3 is wholly depend upon calculation of capacitance. Okay, so see here, हा जो सेकंड पार्ट आहे दॅट इज इंडक्टन्स, हा खूप इम्पॉर्टंट आहे इन युअर पॉवर सिस्टीम. ओके, बिकॉज ऑल द कॅल्क्युलेशन्स आर देअर, सो मेनी formulas, so many equations are there in this equation, in this part, that is nothing but inductance. ओके, जर हा इंडक्टन्स व्यवस्थित समजला तर युनिट नंबर 3 जो आहे तो सी हिअर, हा जर याला या युनिटला समजायला जर समजा तुम्हाला 6 आवर्स लागत असतील, राईट, तर युनिट नंबर 3 समजायला फक्त 2 आवर लागतात. बिकॉज द बेस ऑफ the unit number 3 is nothing but the calculation of inductance. Okay, so inductance is the most important part in this unit number 2, because unit number 3 is fully dependent upon this. Okay, so this is unit number 2. Now we will start the unit number 2. Before starting unit number 2, we will see the syllabus of unit number 2. So see here, these are the syllabus of unit number 2. We have to see some major electrical equipments. So in that major electrical equipments, see here, some parts are there, that is nothing but descriptive treatment of alternator, exciter and excitation system. That means we have to see excitation system. Okay, we know that, or you have already seen, in every power plant one component is always present. That component is alternator. Okay, after the turbine, alternator is always present. Okay, this alternator has some excitation system, because this alternator require prime mover. Okay, now see here, डायरेक्टली आपण जे पॉवर स्टेशन पाहिले त्याच्यामध्ये डायरेक्टली अल्टरनेटर रन झाला नाही. व्हेनेवर देर इज रोटेशन ऑफ टर्बाइन, देन ओनली अल्टरनेटर विल स्टार्ट. That means this alternator requires excitation. Okay, now we have to see what are the descriptive treatment of an alternator, exciter and excitation system. Okay, now see here, in your machine 1 or machine 2 subject, okay, that will be taught by सोनाली मॅडम. ओके, सोनाली मॅडम जो तुम्हाला मशीन 1 किंवा मशीन 2 सब्जेक्ट शिकवत आहेत त्याच्यामध्ये अल्टरनेटर हा एक युनिटच आहे. ओके, अँड इन दॅट अल्टरनेटर युनिट तुम्ही हे जे एक्सायटेशन सिस्टीम आहे त्यामध्ये खूप डीपमध्ये पाहणार आहेत. ठीक आहे, आपण या युनिटमध्ये फक्त जस्ट इंट्रोडक्टरी पार्ट पाहणार आहेत. कशा प्रकारे एक्सायटेशन सिस्टीम असतात, किती टाईप्सचे एक्सायटेशन सिस्टीम आहेत, हाऊ द circuit of that excitation system are there. Okay, that only we will deal with these things. Okay, that means here we are going to only deal with descriptive treatment of excitation system. Okay, that means we have to see how the structure of this excitation system is there, what is the figure of that excitation system, and how this excitation system will treat, or how the excitation system will work. That we have to only deal in this unit number 2. Okay, because we are not going in detail for excitation system, because this excitation system you have been taught in machine 1 or machine 2. I think it's been in machine 1 only. Okay, machine 1 मध्येच आहे alternator. Okay, after that we have to start a transformer. Now everybody know that Sonali madam have already taught you the transformer. Okay, yes or no, please tell me.
Yes, sir.
Okay, now see here. Okay, now
Yes,
see
sir.
here. If any question regarding transformer are there in our question paper, you will able to solve this. How transformer will work? What is the working principle of transformer? Okay. Now primary coil and secondary coil, all these things are there. Okay. Now you are able to solve this. Okay. But we will just see how this transformer are there, how the internal structure of this transformer are there, what is the circuit, equivalent circuit of the transformer, and what are the different types of transformer and which transformers are used in our power system. That only things we will study in this section. After that we will see what are the different control panels are there. Okay, after that last is nothing but we have to see metering and control room equipment. Okay, you know that, or you have visited the substation. In that substation control rooms are there. Okay, now we have to see what are the different equipments are available in the control room. Okay, so these are the major equipments that we have to study in the section number 1. And in the section number 2 inductance are there, and in the inductance we have to see first what is the definition of inductance. Okay, what is the physical dimensional formula for inductance. Okay, after that we have to see a formula for inductance, and then we have to start calculating the inductance of transmission line. Okay, त्यानंतर आपल्याला ट्रान्समिशन लाईनचा इंडक्टन्स कॅल्क्युलेट करायचा आहे. राईट, नाउ फॉर दॅट पर्पज टू बेसिक कन्सेप्ट्स आर देअर. ओके, two basic concepts are there, that is, see here, one conductor is there, right? So that conductor is having inductance by two ways. Okay, कुठल्या पण एका ट्रान्समिशन लाईनला इंडक्टन्स हा दोन वेने असू शकतो. फर्स्ट, inductance due to its internal flux, right? And second असू शकतो inductance due to external flux. Okay, हे दोन खूप इम्पॉर्टंट आहेत. फ्लक्स लिंकेज ड्यू टू इंटरनल फ्लक्स अँड फ्लक्स लिंकेज ड्यू टू एक्सटर्नल फ्लक्स, हे दोन जर समजा व्यवस्थित समजले, so we can calculate inductance. We know that what is the formula for inductance. Can anybody tell me what is the formula for inductance? Or just tell me the formula for flux.
L is equals to I du by dt.
No,
N d phi by dt.
L d phi by dt. Okay, so see here, have you know this formula? Phi is equal to Li. Phi is equal to Li.
Yes, sir.
Phi, that is flux, is equal to Li. Okay, now see here, only one conductor is there, then this formula is phi is equal to Li. Okay, if there are n number of turns, right, if n number of turns, then formula become n psi is equals to Li, right? N is number of turns, psi is flux linkage. Okay, L is inductance, and I is the current flowing through the conductor. Okay, now in this section we are going to study with one turn conductor, so that n, instead of n psi we will just take phi, right? So phi is nothing but magnetic flux, that is equal to L into I, where L is inductance and I is current. So we can, in this formula we can calculate inductance. So inductance L is equal to phi by I. Okay, phi by I, right? Now see here, with this section or with this concept, first we have to calculate phi, right? If we have calculated phi and put the value of phi in this equation, we can find out inductance. So first we have to see in this section, first we have to see flux linkage due to internal flux, and second thing, flux linkage due to external flux, right? ह्या दोन खूप इम्पॉर्टंट कन्सेप्ट आहेत. ह्या दोन जर इम्पॉर्टंट कन्सेप्ट समजल्या तर हा पूर्ण चॅप्टर खूप सिंपल होऊन जाईल तुमच्यासाठी. इफ दीज कन्सेप्ट आर नॉट अंडरस्टँड प्रॉपरली, राईट, त्यानंतर एवढा वर्स्ट चॅप्टर होऊन जाईल तुमच्यासाठी हा, की काय चालू आहे काही समजणार नाही. सो दॅट these two important concepts are there. First, flux linkage due to internal flux, and second concept, flux linkage due to external flux. ओके, एक कंडक्टर आहे, त्या कंडक्टर मध्ये स्वतःचे फ्लक्स पण आहेत, त्याच्यामुळे आपल्याला फर्स्ट कॅल्क्युलेट करायचं आहे flux linkage due to its own internal flux, right? And second, we have to calculate flux linkage due to external flux. आणि जर हे दोन्ही flux linkage आपण ऍड केले, if we have add the flux linkage due to internal flux plus flux linkage due to external, then we can get an inductance of that particular conductor. Okay, that is the concept about inductance. So after that we have to see inductance due to internal flux of two wires single phase line, as well as we have to see composite conductor line. After that we have to see geometric mean distance. What is the concept of geometric mean distance, right? GMD, we know that GMR, geometric mean radius, as well as geometric mean distance we have to see. After that we have to calculate the inductance of three phase line with equal and unequal spacing, right? If the spacing is equal, then it is called as symmetrical spacing. If the spacing is unequal, then it is called unsymmetrical spacing. Okay, now this is a vertical spacing. So all these concepts we have to see in the inductance. Okay, या पूर्ण चॅप्टर मध्ये फक्त दोन कन्सेप्ट महत्त्वाचे आहेत, फ्लक्स लिंकेज ड्यू टू इंटरनल फ्लक्स अँड फ्लक्स लिंकेज ड्यू टू एक्सटर्नल फ्लक्स. हे दोन गोष्टी जर व्यवस्थित तुम्ही क्लिअर केल्या तर दिस चॅप्टर इज सो सिंपल. ओके, खूप सिंपल होऊन जाईल. आणि हे सिंपल जर गेल झाला तर थर्ड चॅप्टर, दॅट इज नथिंग बट ओनली कॅपॅसिटन्स. ओके, थर्ड चॅप्टर इज नथिंग बट ओनली कॅपॅसिटन्स will be also a simple for you. Okay, so this is the syllabus of the unit number 2. Okay, now in your practical, right, in your practical, second practical is nothing but descriptive treatment of alternator and excitation system. That means in your practical number 2 there is a study of excitation system of alternator. Okay, now we will directly start the excitation system. Okay, now see here in your practical we will see just basic about. Okay, आपण प्रॅक्टिकल मध्ये पण ह्या गोष्टी बघूया, पण आपण आता डायरेक्टली स्टार्ट करूया युनिट नंबर 2, दॅट इज नथिंग बट मेजर इलेक्ट्रिकल इक्विपमेंट्स. ओके, आणि प्रॅक्टिकल मध्ये बघूया आपण काय घ्यायचं. नाउ वी विल स्टार्ट द फर्स्ट सेक्शन, दॅट इज नथिंग बट major electrical equipments. Okay, now see here we will first see what are the introductory part about this. So first we have to know about alternator. Okay, so what is the alternator? Alternator is an electrical machine, right? Instead of electrical machine we have to see as electromechanical device. Okay, because this is an electromechanical device which converts mechanical power into electrical power. So before starting, see here electrical machines are classified into two types. Can anybody tell me कुठल्या दोन types आहेत? Please tell me. Electrical machines are classified into two types. Please tell me.
AC DC.
ओके, ते पण आहे. इट इज बेस्ड अपॉन इट्स इनपुट. ओके, सो सी हियर electrical devices, instead of devices, see here, instead of machine we can say that electrical machines are of two types. First is a rotatory machine, second one is a stationary machine. Okay, see here electrical machines are classified into two types. First is a rotatory machine, second one is a nothing but stationary machine. We know that. What is the stationary machine? Tell me. You know that what is
Transformers.
stationary machine? What is?
Transformers.
Very good. See here, stationary machine is nothing but a machine in which no rotatory parts are there. Okay, so this is example of this stationary machines are transformer. Now the second section is a rotatory type of machines. Okay, now the basic rotatory type of machines are classified into two types. Okay, every every rotatory machines are classified into two types. So tell me, rotatory type कशा classified केल्या आपण?
DC and AC.
No.
So squirrel cage and as squirrel cage, huh?
Okay,
Asleep.
see,
Round
first,
rotor.
that is right. What she said, AC and DC, right, right. Now, rotatory machines are of two type, AC and DC, right. Now see here, एक T diagram सारखं तुम्ही assume करा, मी सांगतोय त्या प्रकारे, right. Electrical machines are classified into two types. Bifurcation करा. First is rotatory, second is a stationary. Stationaryच्या खाली तुम्ही लिहू शकताय what is example transformer. After that rotatory are classified into two types, DC and AC, right. DC machine तुम्हाला माहिती आहे, right, only one machine are there, DC, right. And AC machines, we know that there are how many types of AC machines are there? Tell me how many machines are there? AC machines are there. Two type AC machines are there. Okay, now see here, DC machines, further DC machines are classified into two types. Tell me which are the two types? DC machines are further classified into two types.
Single phase, three phase.
That is also right, but I want every machines, see here the word machines, every machines are classified into two types, that is generator and motor. Okay, every machines are classified into two types, generator and motor. So DC machine are classified into two types, that is nothing but DC generator and DC motor. Okay, so see here, what is DC generator? What is DC generator? A mechanical power or mechanical energy will convert it into a DC electrical energy. Okay, that is called DC generator. What is DC machine? DC electrical power will get converted into a mechanical power, that is called DC motor. In similar way, AC motor are classified into two types, that is generator as well as motor. Okay, now AC generator, how many types of AC generators are there? Tell me how many types of AC generators are there? Two types of AC generators are there, induction generator and synchronous generator. Okay, AC generator and synchronous generator. We know that there is a synchronous speed. Okay, when our rotor is rotated with a synchronous speed, that is Nr is equal to Ns, that means rotations of rotor having the same speed of synchronous machine, then that machine will be called as synchronous machine or synchronous generator. Okay, and alternator कधी मग induction generator कधी म्हणायचं मग? Tell me. Nr is greater than Ns. Okay, when Nr is greater than Ns, then it is called induction generator, right? So see here, synchronous generator is also known as, can anybody tell me synchronous generator is also known as?
Alternator.
Very good. That synchronous generator is nothing but alternator. Okay, that means in the alternator, rotor speed, rotor speed is equal to synchronous speed, so that we will called is at synchronous generator. Okay, हे एक प्रकारचं जनरेटरच आहे, right? And the speed of that generator is same as synchronous speed, so that we will call it as synchronous generator. Okay, so the second name of alternator is a synchronous generator. And the second name of induction generator, can anybody tell me what is the second name of induction generator?
Asynchronous generator.
Very good. Asynchronous generator. Why? Because the speed of rotor is not same as the synchronous speed, so it is called as asynchronous generator or induction generator. Okay, see here, every power plant uses alternator except wind generator. Okay, wind turbines. See here, windmill मध्ये induction generator यूज करतात, right? windmill मध्ये asynchronous alternator वापरतात, but in remaining other power plants uses synchronous generator, that is nothing but alternator. Okay, so alternator is an electrical machine which converts mechanical power into electrical power by the principle of electromagnetic induction. Okay, this alternator will depends or will work on which principle? Electromagnetic induction, and that alternator converts mechanical power into electrical power. So see here, this is alternator. Alternator start झालाय का तुमचा मशीन मध्ये?
नाही.
Yes or no?
No,
No,
sir.
sir. No, sir.
Okay, okay.
No, sir.
Okay, just wait for 1 minute. ओके, नाव सी हियर, अल्टरनेटर झालेलं नाहीये ना अजून? सोनाली मॅडमने स्टार्ट केला नाही वाटतं. येस ऑर नो?
No, sir.
ओके,
Yes, no, sir.
okay, okay. Now see here, this is the alternator. Okay, so see here, in this alternator, this outside part is known as a stator. Okay, this outside ring or outside circular part is known as a stator, right? Now in this stator, see here, this N and S poles are there. Okay, this N and S poles are called as a rotor. Okay, now this stator, right? Now this stator containing, see here, 3-phase supply, that is nothing but a field winding is there, right? So all these internal structure you have seen in a machine 1. Okay, now we will just see what is alternator, what is the structure of alternator, what is the circuit of alternator. Okay, now see here, alternator are the primary source of all the electrical energy we consume, and it also the largest energy converters. That means, see here, this alternator is nothing but an electromechanical or electromechanical device that converts mechanical power into an electrical power. So this alternator is a primary source of all the electrical energy that we consume, and it is converts mechanical power into an electrical power. So after that, this alternator system or this alternator requires some excitation system. Okay, so this excitation system is nothing but which is used for providing the necessary field current to the rotor winding. Okay, now see here, this stator is having one winding. That winding is nothing but a field winding, and this rotor is also having one winding, and that winding is nothing but an excitation winding. Okay, see here, field winding is present on a stator and excitation winding is nothing but a rotor. Okay, now this field winding has to be excited. Okay, so for that purpose some excitation system will be employed. Okay, now what is the definition of excitation system? So see the definition: the system which is used for providing the necessary field current to the rotor winding of a synchronous machine. Such type of system is called as an excitation system. In other words, excitation system is defined as the system which is used for the production of flux by passing current in the field winding. That means excitation winding is required for the production of flux. Okay, the main or important function of this excitation winding is nothing but the production of flux when it carries a current. Okay, the main requirement of an excitation system is reliability under all the condition of service. Also, it is used for the controlling purpose, and it is easy of maintenance. This excitation system is having the stability, and this excitation system is also having the fast transient response. That means all these are the characteristics of our excitation system. These excitation system are easy of maintenance. Also, it is having the stability. Also, it is fast for the transient response. Okay, it is having the simple in control structure, as well as it works on all the conditions. Okay, after that we will see the amount of excitation required depends upon the load current. Okay, now see here, we know that excitation system is required for the production of flux. Okay, now this excitation is depends upon the load current as well as the load power factor and speed of the machine. Okay, now see here, every excitation of an alternator will be depends upon these three things. First is load current, second is a load power factor, and third one is a speed of machine. Okay, if these three things are more, then excitation should be more. Now see here, the more excitation is needed in the system when the load current is large, right? When the load current is large, more excitation system is required. Okay, now the speed becomes less and the power factor of the system become lagging. Okay, we know that whenever there is a lagging power factor, then inductive load is there. When there is inductive load, it requires a large load current. If the load current is large, speed become less. If speed become less, then excitation is more. Okay, so these all the related things. Okay, so here whenever there is a lagging load, power factor becomes lagging, so that load current become large, right? If the load current become large, speed become less. If speed become less, excitation require is more. Okay, so see here, excitation is mainly depends upon three things: load current, load power factor, and speed of the machine. Okay, the excitation system is the single unit in which alternator has its exciter in the form of generator. Okay, see here, this excitation system is the single unit in which each alternator has its exciter in the form of generator. That means alternator, we know that what is the function of alternator is it has to generate electricity. Okay, so see here, every alternator uses exciter in the form of generators. The centralized excitation system has two or more exciter which feeds the bus bar. Okay, now see here, some alternator systems are utilized for the centralized purpose. If the centralized excitation system are there, so that central excitation system has uses two or more exciter, right, and which are feed the bus bar. Similar way, the centralized system is very cheap, but the fault in the system is adversely affect the alternator in the power station. Okay, now if suppose in any power station, if two alternators are there, so instead of using separate exciter if we have used the centralized excitation system. Okay, now this centralized excitation system becomes cheap. Instead of using two excitation system, we have used only one, so that cost will decrease. Cost will decrease, but this central excitation system having some disadvantage, that is nothing but if the fault or occurs in the system, it will adversely affect the alternators in the transformer, in the power station. Okay, now we will see what are the different types of excitation system. The excitation system is mainly classified into three types. Okay, every excitation system of an alternator are classified into three types. So these three types are: first is DC excitation system, second one is AC excitation system, third one is static excitation system. Okay, first is DC excitation system, second one is AC excitation system, and third one is a static excitation system. Further, AC excitation system will be classified into rotor excitation system and brushless excitation system. So how many excitation systems are there? 4 excitation systems are there, but broadly classified into 3 types only, and these 3 types are DC, AC and static. Okay, DC, AC and static. AC are further classified into rotor and brushless. Okay, so these are the excitation system of an alternator. Okay, in next lecture we will see in detail about this excitation system. Okay, in next lecture we will start DC excitation system. Okay, just I will show you the figure. So see here, this is the DC excitation system. Everybody please take a screenshot of this and try to search on YouTube about the DC excitation system and try to understand the concept behind the DC excitation system. Okay, so this is your homework. Try to search DC excitation system in YouTube and try to understand the concept behind this. Okay, in next lecture we will start DC excitation system. Is there any problem? काय प्रॉब्लेम आहे का आतापर्यंत जेवढं लेक्चर झालं त्यामध्ये?
No, sir.
No, sir.
Okay.